Swayam Prabha. Digital India. Educated India.
Welcome back to our discussions on mine closure and sustainability planning. In that, we were discussing about different tools and techniques for mine closure. Though there are wide range of techniques, particularly a lot of statistical methods, lots of optimization technique, many operational research methodology, they are used in different data analysis and decision making tools. But two major tools that are exactly used in all mine closure related planning and execution is remote sensing and GIS. We have already discussed briefly about what is remote sensing, that is how you acquire different planning inputs for decision making. But thing is that once you get the information from an area, to analyze it, to process the data, keeping the spatial distribution of it, the best way or best tool is to have a geographic information system, shortly called GIS. So today I will be giving a brief introduction of geographic information system. However, this system will have to be learned by learning how to use some of the software which are available. Some of them are freely available, like QGIS and all. So you will have to get those software, download to your computer and do some practice of map making, because the geographic information system, it is nothing but how you can get the spatial informations. In this, the basic concept is map making, that mapping, that how you exactly you develop a information system where that your that is locationally distributed data or spatial data that can be mapped and analyzed. All of you have got this your experience of using Atlas. You may be remembering how you were playing as a school kid about this finding out towns and rivers from an Atlas map. Now that Atlas, which is nothing but where there are certain symbols like your towns with a small circle, with your rivers as a line, and it is represented on a map, and when you draw a map, it is exactly full of data. And also you know the relational distance there, how you will go, what are the hindrance in between them, how they are spatially distributed. This information now got digitally captured and brought under an information system. So that geographic information system will be covered in this lecture, because every object present on the earth can be georeference. Georeference means it has got a latitude, longitude and elevation informations are there. Now this exactly, whenever you have talked about this Atlas, a map is nothing but georeferenced information are placed together, where one relative to the other you can find out. Whether in a map you can see whether Guwahati is in the northern bank or southern bank of river Brahmaputra, or we can say that whether what is the your distance between the river Ganges and river Brahmaputra, where is the distance of there, where the sources, how they are distributed over there. So this type of queries you can make on a map, because a map is a representative of the surface of the real world on the plain sheet of paper that you have seen in the Atlas. So in a geographic information system, it is a combination of map and data linked with the map. So, we are exactly what is the basic database concept has been brought into place the geographically or spatially located information, and that is why it is a you can do all location related analysis with them. You can tell in that in a particular district, that is what is the distribution of the rivers in which way is there, or how much of the total area of the district is being used as an agricultural purposes or mining purposes, that you can get derive those information when you are having a geo-referenced map. Everything is represented with a definite symbol, you understand, and then their information regarding its length, regarding the area bounded by some that closed polygon, those things when you can find out, or you can write the descriptions of those places or the identities on a map. That is geographic information system in a nutshell. So, here this georeferencing is the main keyword, and there we give a lot of homage to this father of GIS. Exactly, it was that Roger Tomlinson, who was he was basically a British, but he worked in Canada, and then he developed in the in 70s that how before that he worked of course as a surveyor, and then he worked as a geographer, and then in the 60s he developed this methodology. And when the computer that you developed with the computational knowledge developed, with that they started working with to develop a geographic information system. So, this Roger is respected as a father of GIS, and this exactly founded as a laboratory in Esri, which developed later on this ArcGIS, a very well known software. Now, we have saying about this, we can now define what is GIS. So, as we said, it is exactly a product of our digital development or the computerization. A geographic information system is a computerized integration of database management technology with automated mapping and data analysis tools. And what it does? It is why it is developed to capture, store, retrieve, manipulate, analyze and display all these activities which are done on a database, and display all forms of spatial and non-spatial information graphically. So, you can make a map out of it. Those data you capture in the map form and in a digital form, and from there you can create again a map which will relate the data spatially for reporting, planning and decision making in order to facilitate better management of geographic area. I think a lot of things are put into in one definition. It can tell what is GIS, what it does, how it is worked, everything is put in one sentence. So, if you understand that it is a computerized integration, you can have an automatic and you can automate it to analyze different information. You can capture from there that all the real life information can be captured and placed it over here. You can store it and you can retrieve the way you want to do report somewhere. You can take out the data from there and then you can manipulate. You can just compare, you can add, you can subtract, that manipulations can be done, and so that you can analyze. After that you find out a decision. Analysis is to take some decision, and then whatever you have found you can display. Say you can see in a particular mining area, you have done the plantations, now you have geotagged all your plants and then you have kept those things in a GIS, and then you know that relevant informations are also placed over there. You make a query that what is the total plantation area after say 1990. So, it can bring a map giving a particular color to the all plantations where it is done in 1990. Then you can see that what are the plantation area before 1990. So then you can find out in an area how this has gone. Now in that, if you make that what is the plantation of a particular tree, say sagun tree in this particular location, when you get that one, then you can take an intersection of these two maps, then it will show that is in 1990 how many plantations were there on, say, your eucalyptus. You can find out, then you can tell this is the thing. So like that you can retrieve and then display. These are all will be helping in decision making in a closure or in a mining or a management. Everywhere such type of things will be there. So in a geographic information system, you are bringing the real life world, and for that you will have to do the data collection. After the collected data will have to be managed by data management, and then data can be managed for getting different information by doing a proper analysis with it. After analyzing, the result can be data presentations, how you will present it, and then that presented data can be used for planning and design, and then you can give these things for the implementation. Once it is implemented, you can monitor. So that will create a new real world, and in that new real world you will be getting new data and the system will continue. So once you get a GIS installed, it can be used for in future, only you will keep on updating the things. So this geographic information system is a computer based information system, and it is digital representation of the geographic features present on the earth surface and the events that take place on it. So it is a very small way of telling what is GIS. So basically GIS is nothing but a spatial database management system, and it has got automated mapping and data analysis tools. When we say a database management systems, it is that exactly a database. It captures the data, it retrieves the data, it keeps in such a methodical way that you can query it, you can represent it, you can analyze and do it those things. But here this data is keeping the information, not only the temporal relationship, but also your spatial. That means the latitude, longitude and elevation informations of all the data can be placed over here. And as it has said in the previous slide, it captures, store, retrieve and display and analyze, and it is exactly facilitated for interpretation of what is happening and how you will report and what exactly you will be planning out of it, or how will you take a decision making. After the mine is closed, how much barren area has been left with? After the mine is closed, how many plants and buildings have been demolished and decommissioned, and now what is there? How much area is full of your debris? How much water body is getting affected by the leachate coming from the dump, or how much area is convertible to agricultural or cropland? What are the area that that are not yet stabilized? This type of query you can make on when you are having all the information of your mine closure area in a geographic information system database. So now coming to little bit of when you are using this as a your tool, what exactly there it is. If you have to have a data input and then data management, that is in the database. Now that database exactly will be operated with a required that software, it will get the data and manipulate and analyze them. Now in the analysis, the beauty of this geographic information system is every data is georeference, means it has got its unique latitude, longitude and elevations, and that your area, if it is a, it can take your point data, line data, and then this your polygon data, and then it has got its own shape. If it is a polygon, its area, all can be done. And you can think of, if you take a 4 transparent sheet, on it 1 transparent sheet you draw only these rooms boundary, and then you give the location of this dais. In another transparent sheet, you just draw the chairs and tables how it is there. In another transparent sheet, you just draw where there is exactly the projections of the light or projection of the speaker it is coming. Now, if you keep this all three together, you will see that exactly what is there in the room. That is what is done as it is there. Say each of that layer is called a coverage. Here a mine coverage is there. Here maybe the asset, the buildings and all are here, that is a plant, buildings, workshop. In another you are having the trees, rivers, lakes and all are there. In another you have got the land coverage, that river, roads and telephone lines and all. Now, if you put all together, you will be able to see that what is there in a mine. That means in a database when you form, you can have that an integrated drawing, or you can take one layer. Now, if you take the building layer, a new building is coming up or one old building is demolished, you change it and then you insert it over here, again you are that main thing, whatever the new look will be coming, you can get. That is what is done in a GIS. So, in that main component of this, exactly to GIS to work, it will have to have the software that like a S3 or GIS or QBasic or the Geomedia, Geomatica. There are different companies have got different software, and then you will have to data what exactly you have collected from your area, and then you have to learn the procedures how this data will be put into the GIS, and then you will have to know the hardware, what type of computer, what type of how you will get the data input, whether you need a scanner or whether you are just getting a digitally, whether you are taking a photograph and that will be taken. That your hardware part is necessary, and of course the people, trained people who will handle all these things, and that are brought in a GIS. Now, that is what exactly when you want to take a decisions regarding that exactly what you will be doing in a particular area, you need to know the topography, you know the land use, know the geology, maybe the noise level, the production level, mining level, dust level, all are different coverages, and then you can make a thematic map combining whichever the feature you want, and then this database is there. Then from there you can develop some model and spatial analysis, that what will happen, whether that in a which directions the traffic can give a problem for the, that is your that whether the traffic will be affecting the school children, the primary schools are there on the roadside or not. These things can be a model, and then you can create some scenario. If the road is going in this particular direction, the dust generated from the road and tire interactions, because the wind velocity in this direction, so the villages and schools will be affected over here. Now, if you make the road going little bit in an away from there under the wind directions, that it will be exactly the school will not be affected, the township will not be affected, the dust will be going towards a forest, so that you can change the orientation of the road. So, that means you can create different scenario in, and by changing that particular locational things, whether the impact or effect can be changed. So, now you understand, once you put the things in a geographic information system, you can take a decision. So, that is why it is a tool for planning and tool for designing. So, having said that, if you want to go really to work with a GIS, you need to know how the exactly data is managed over there. In your computer, in your mobile or in a computer, normally you give it a number or you give the text. So, that is called your alphanumeric data you are giving as an input. But in GIS, the data type, those numeric, which can be, as you have seen in your computer, you say that integer, double, or this the float, like that you say the data type. Now, here some data types as a node or line or area. These are a format of data, unit of data, which can be going over there. And these nodes, lines and polygons, they can be combined together to form a raster image or a vector image. The two type of, we said earlier also in remote sensing, that a raster image where the patch of all things are illuminated with a color, it is a raster form, but from there when you find out the distinct lines and things like that, you are vectorizing these things, you get a vector model of the data. So, in a GIS data structures, what is done? You are having the existing map of the mine, your townships and other, you have got some field observations and you have put some sensors to collect some information. So, those are, they will be coming from different way, that is your field observation can be by scanner, by test file, by digitizer, then your sensors can bring a magnetic data in a tape or in a your disk, it may come, and then existing interactive terminals may be there, all these will be coming as an input, and that data input will be brought into this database, and then whatever you want as a vector or raster, you can draw that your map. So, you get spatial geometry, means you can know the relational locations over there and you can find out how your things are there. Now, here you may get tree, road, river, lake and all the different features. Those features, their attribute values are given in a tabular form, and then when combining together you may have the GIS features. That means you get a map and then you can read, say here which particular entity is taking maximum, that you can find it out. So, once you put, then from there you can draw the contour, you can make a digital elevation model, and then in the GIS, after entering all the spots, lines and spots informations, then they do the proper algorithm to make them the contour. So, this contour mapping, where the surveyor go do the your with a totalization or with your earlier with a chain, then this theodolite you get it over there, and then you get the points elevations, and from the points elevations again you put, you can draw contour, that can be made. Now, this contour can be brought in a 3D manner and you can get a digital elevation model by which you can see that what is the terrain look like for a particular site. So, this is how that exactly geographic information system allows you to visualize and see what it is. So, now once you have developed the GIS, this can give you a decision support. That when we say as a decision support, it is exactly it's some rule and some data. That rules are often called as a function. Now, the decision maker, they can ask certain questions, and then on the basis of that, when you get the information from there, you can take a good decision that what to do with that particular site or things. So, what are the information it can give? You can have a question regarding the location, that is what is at a particular locations or what is the distance between them. You can find out a condition, that is where it is in the upside or downside, or it is right or left, those conditions of location you can find out. You can find out also, you can get the maps of different time you collect, and from there you can find that what is the trend of it. If the river is here deeper, you know that sometimes because of the flood that the bank erosion takes place, the river moves, that is called river migration. Now, if you see that the geographic information system of every 3 years from the past now, and then go every 3 years or 5 years past, then you can find out, put the all data in one table, and you can find out what is the trend of shifting of a river. Similarly, you can find out, that is you can model what will happen if this is happening like this. So, you can develop a model with the parameters, the variables, and then when it's changing, then you can find out what is influence on the other. And also sometimes you can non-spatial equations, that is just only not related to the location, but in general certain questions can also be obtained for here. So, for example, what is the total population, you can find it out, and spatial questions also, what is the total populations say on the rivers near the river bank, spatial questions will be coming, they will be looking into one particular area. Now, here that GIS will have to be given data input, as I said. Now, that data input can be given by topo sheets, it can be given by satellite imagery, it can by aerial photograph, it can get from the collateral data from the field visits. You can go to the environmental department, can give you some information, agricultural department can give you some information, even the local shop there, how much revenue they have collected, from which area, type of things can be coming. So, there are different source of information, you collect it and digitize it and put it in a digital form in the GIS. And another thing is that global positioning system, which is another tool, and then how exactly the location of a particular space can be obtained very accurately by GPS, and all these things are going to give the data to your GIS. And once you are getting the data, once you are getting the map, you are developing the relationship and functions, then the GIS can do a lot of work. It can do the natural resource management, it can do waste management, groundwater modeling, environmental impact assessment, environmental compliance and permit tracking. That is how government will be saying whether you are following the rules and regulations or not properly, and then if you are given a permission for doing something in some particular way, if you are violating or not can be monitored through this, and then your renewal of permissions may be based on this. Then you have got a policy assessment whether the policy which you are following is okay or not. Also the site remediation, if the site has got totally degraded, how will you retrieve it? If you have got in a mining area, you have spoiled the water has now a lot of pollutant not suitable for drinking, then what type of policy you will have to make over there can be again handled in a GIS giving spatial directions. Maybe given that this river up to from this distance to this distance, nobody can do a fishing over there because there are concentration of pollutant is high. Something like that can be insisted on a policy assessment. Then site remediation, how you will exactly improve the condition of it. Then how will you monitor the site after the mining is over, that post mine monitoring, and the vegetation, how it is. I was giving you some example like that. All these things can be done by geographic information system. I think by now you understand that this is a very, very important tool, and if you want to develop your career as a mine closure planner or mine closure executive, or you want to get your new business to work with the mining company to help them or the providing services to them to close a mine, these tools you must learn. Now, that there are many related tools along with this. You may have this database management system, statistical analysis system, computer cartography, map making, desktop mapping, remote sensing system, global positioning system, computer aided design. These all things can be brought in the as a associated tool, and they will enhance the capability of geographic information system. Now, such type of things were developed in our this is a map I generated I think in 2003 or 4. This is a Umrer mines. There you can see that once all this data were put into GIS, we could develop this map. You can see here how the Am river is shown as a this river. Then your mine boundary, this red, it is a lease whole area of the mine. You can see here the dump, all this blue color is a dump, that there are so many dumps are there. Then you can see where the plantations are done. So you can see that these are some agricultural plantations, these are the dump where the plantation has been done, and by that exactly you are developing a map on a GIS with the legend can give you all the things available over there. It is done on a particular scale, so you can find out in a real life where the quarry or where the plantation is there. This type of things can be done. So once also that is done, you can create something. There is a in the geographic information system, you can give a query, say here we have given the plantation area greater than 1998. So that means which are the area where plantation was done after 1998. So, it was a query I gave in 2004 and then these were highlighted. So, that means it was there. So, now if such type of system, this I am working, that is a call, it will be .hsp file that has been come over here. You are keeping this GIS in your mind and you keep on updating the data. Whatever is required, you periodically update, then this will become a decision making or planning tool. So, that is why you may be knowing that I was telling in your previous class that in the first class that to have a mine closure properly, all the existing mines at present who are working at the mines level, at the colliery level, they must have a system developed with this geographic information system, so that all data are captured at the source and without any distortions kept in the GIS, and that can be a big tool for making a lot of planning, lot of things. So, this is a very important tool. One applications we did in say Mumbai during the 2004, we did a study to place the air pollutions, where exactly the SPM. From here you can see the different color give the concentration of your the PM10, that we can find it out depending on the wind velocity, and you are seeing here which are most dust laden area. So, similarly that GIS can help in monitoring final shape of a land, what it will be there, that quantity and quality of vegetation, afforestation plan, tree plantations and health of the trees, lake area, wildlife, all these things. And in the environment also, it can say that what will be the rainfall rate, that is your what would be the sewerage treatment plant, how the air and water quality, then location of fire hydrants and all, how it is there, all that your environment in that area, different entity, how it is located there, information can be entered into a GIS and you can retrieve and use for your planning purposes. So, some of the common GIS software, you may note down the name, that ArcGIS, QGIS, GrassGIS and PostGIS. They have got a different functionality. ArcGIS has got the full featured of things. Then they provides the Environmental System Research Institute, that exactly they are the developer, ESRI, that is Environmental System Research Institute of America. They have developed this particular software and which is very useful. You can see these websites link and then have a basic idea about what this software there, because you will have to master one of this. Then this ArcGIS desktop ESRI, this is one I recommend, that if you are working with a company, that company should buy these things and have it and then develop the expertise to use it. QGIS is very popular, it is a free download, all the students will be working on it and then they will learn it, and then the company will have to provide them the sophisticated better software so that they can give a better results. So, geographical information system based approach provides an intelligent and interactive decision support for visualization and modeling of geographic features, which is very, very important for mine closure planning and monitoring and execution. Then remote sensing primarily is a tool for acquisition of data, whereas GIS is primarily concerned with the analysis of data for various applications, and those applications includes your resource management, land use study, route finding and locational analysis, etc. So, very specific now, for the specific purposes you will have to learn it, and it is not very difficult. You may require only 1 month with your level of computer knowledge. You can learn in 1 month how to use it, and then of course you will be becoming a lifelong learner. You go on adding new technology, new things over there, new algorithms are coming up every day. Their way the data can be seen and things are getting modified, there is there. Visualization and analytical features of GIS can provide more information and convenience to the users. You can very easily convince your boss that yes, this is what I want to do, because if I don't do this will happen. You can give as a proof, you can create a scenario that you want to do a plantation in particular area, if you do not do, that area will get destabilized, and what will happen after that, you can create a scenario and show to your management. This is the thing. So, that it helps in taking decision. So, environmental impact assessment is one of the expert and analytical procedure that can be handled using GIS, and examining the impact of a project on the environment, what will be the impact of mine closure can be done over there. There are many textbooks that say, and there are many articles, there is a full of material. If you search, you will get. These two are some general informations I have given to you. I hope you will be using this particular tool for your learning and then the earliest you start to learn GIS and remote sensing is better for your future career. Thanks.